We now solve example 4. So we are given a force, which is a varying force. Why do I call it a varying force? Because it depends on the position. So as the particle moves from one point to another point, when a force is applied on that particle, the force keeps on changing in terms of magnitude. Yes. So the previous case, we are dealing with the work done by constant force, where the force is constant throughout as you apply it on an object. Now in this case, this force is given as a function of x. So meaning as a particle changes position, the force also change in terms of magnitude. For instance, if the particle is at the origin, we replace by 0, we are going to have negative 2 Newton force. When the particle is at a position x is equal to 1, it will be 1 Newton. So you see that at every point, the force is changing as the object is being displaced from one point to another point. So this is a variable force. And the work done by a variable force is given by the integral of this force with respect to x, the displacement. So in this case, the work done by the force is given by the integral of the force with respect to x, since the particle is acting in the x-axis. If it was in the y, we can say with respect to y, if the force was acting in the vertical direction. So, what does that mean? So it means that, now, let me explain this. The particle has been given limits in which it is moving. So now, like in this case, we are told that find the work done when the particle is moved from initial position 5 meters to final position 8 meters. So we have to put the limits when you are given from initial position to final position. So the work done in this case will be integral. What are the position? Initial position here is 5 and the final position is 8. Integral of f, but f is simply 3x squared minus 2 with respect to x. So what does that mean? It means we have to integrate this expression with respect to x, the expression for the force. When we integrate, we get 3x cubed divided by 3, remember integration, minus 2x plus a constant of integration. Now, remember the limits should be there. We are moving from x is equal to 5 to x is equal to 8. So the work done will be equal to x cubed. This will divide, will cancel x cubed minus 2x plus a constant of integration when you are moving from x is equal to 5 to x is equal to 8 meters. So, what does that mean? We have to replace the value of x by the limit. So the one on top is known as the upper limit, this one is the lower limit. It means that we have to work out this now. We are going to replace first upper limit minus the lower limit. This means that first we are going to replace x by the upper limit, which is x is equal to 8. So 8 cubed minus 2 times 8 plus a constant of integration. That is the upper limit minus the lower limit. Now we take the same expression, we replace by the lower limit, which is 5. So be 5 cubed minus 2 times 5 plus constant of integration. So you see that when we evaluate this, here we are going to find 12 minus 16 plus constant minus 125 minus 10 plus constant. So when we evaluate, you see that the constant minus constant, so the constant will be cancelled. So it's as good as not even including it when we are dealing with the limits, because it does not have any effect, whether we include it or not. So when you evaluate, the final answer you should get is 381 joules